Hi there. Today we're going to take this rational expression thing one step further. We're going to solve rational equations. So we've done a lot of multiplying, dividing, and adding and subtracting, but now we're going to throw an equal sign in there, which means that we're going to have to solve for the variable that's in the rational equation. So here's our first example. I kept it kind of simple with just monomials in it, and you kind of treat it like we did when we were adding and subtracting. But before we get started, if you'll notice the directions, typically we'll say solve the rational equation and check for extraneous solutions. Extraneous solutions are solutions that in the process of you solving you've come up with, but they are extraneous, meaning they don't actually work back in the problem. So we talked about this when we first started simplifying. We talked about what's the domain, or what are the excluded values. You always want to be careful of what your domain is before you get started so that your answer will still be part of that domain. So in this number 1, if you look at, you got a bunch of fractions. Remember that you don't want fractions in your denominator. So I look at each one of those denominators and I try to figure out what would make those be 0. These are all pretty easy. Basically, my domain here would be that I would not want v to equal 0, because that would be the problem. Whether it's to the first power or squared or times 2, I wouldn't want v to be 0 for any of those. So I want to make sure as I solve this that I don't end up with v equaling 0 at the end. Okay, so then the next thing we're going to do. The thing that makes this a little bit tricky is that it's a bunch of fractions. So our first step is going to be to try to get rid of the fractions. And since there's going to typically be addition and subtraction going on, we're going to use that same method of finding a common denominator to get them all to have the same denominator. So when I look at this problem, I see that I've got to have a v. This term here says have a v. All right, this one has a v. In fact, it has a couple of them. So does this one. So we've got the v taken care of. Now you go to the next fraction and you say, well, actually I have to have at least a v squared. Okay, so that one has the v squared, so does this one. This one is only a v right now, so I'm going to have to take this fraction times an extra v so that it will end up being a v squared. And then the last fraction says, oh, and you need to have a 2. So that one has a 2, but the other ones don't, so I'll have to take each of those times a 2 as well. So your common denominator is going to be a 2v squared. So let's write each one of these with that common denominator. So I usually like to, at this point, go ahead and merge those fractions together that were being subtracted. So I'm taking this right here and I'm going to write it as one big fraction. So it's going to be 2v squared for a denominator. And on the top, I'm going to multiply 2v times 2. Now that's not a distributive thing. There's no addition or subtraction that you're distributing through. It's just going to be a 4v minus, and then I have a 2 times 1. That's just a 2. Equals 1 over, this one I didn't have to do anything to. It already had that common denominator. All right, so that's kind of what we were doing with addition and subtraction. Now what's different is I'm going to try here at this stage to get rid of my fractions. And so by having the common denominator here on both of these fractions, what I can do, since it's an equation, I could just multiply both sides of the equation times that common denominator, like that, and I'm just multiplying there. And I'm just now being able to do that because I am just now starting to work with equations. Equations, you can do that because you're doing it to both sides. Alright, so when I multiply both sides by 2v squared, what happens is these 2v squareds can cancel, these 2v squareds can cancel, and then all I have left is 4v minus 2 equals 1. And I don't have any fractions left anymore. That's kind of my goal. That's why I multiply by that common denominator, so the fractions are gone, and then you have this quick little equation. Oops, I thought it was quick. Hang on. I'm going to add 2 to both sides. Just thinking ahead there, so I'm going to end up with a 3. So 4v equals 3 divide by 4. So my solution, v is 3/4. Okay, so what that means is I could take 3/4 and plug it in for v up here in all of the different v's and multiply that all out, and I would have this left side be equal to the right side. The one thing that you have to check, I already boxed it in, but the one thing that you have to check is that that answer that you got, we got 3/4, does fulfill your domain. And in this case, all I wanted was to make sure v was not 0. I did not get v to be 0. I'm good to go. Okay, let's try another one. All right, so again, I have a few binomials in my numerators, but the denominators are all monomials. So again, you have to kind of go through each denominator and decide what is it that's going to be your common denominator. So this guy right here says, got to have an n squared. This one has an n squared. This one has an n squared. All right, this already has it. This one says it's got to have a 2, so we've got to put a times 2 on anything that doesn't have a 2 in the denominator, which is going to be these. Okay, so then again, I like to combine the addition or subtraction fractions that are being done into one fraction. So that'll be a 2n squared on the bottom, and 2 times 1 is 2, plus n minus 6 equals, on the right side I'll have that 2n squared as well now, and I'm going to be taking this 2 and I'm going to have to distribute it through. So it's going to be a 2n minus 6. All right, so once you get to that point and you have the common denominator between the two, I'm going to take both sides times that common denominator. Now I'm writing these over 1 just so that you see kind of how that is similar to when we were multiplying, because then you can just cross off if you have one thing on top and one thing on bottom. But a lot of times I don't bother to put that over 1. Probably after this I won't. All right, and so once those denominators are gone, all I have left is this numerator, which is a 2 plus n minus 6. I could clean that up just a little bit. Let's call it a negative 4 plus n. And on the right side I have 2n minus 6. And then I'm going to subtract n on both sides. And add 6. Okay, so I get n to equal 2. Now before I box that in, I want to check that with my domain. And last time I did my domain at the beginning, it's probably smart to always do your domain at the beginning, just so you don't forget about checking for any extraneous solutions. But in this case, my denominators look very similar. Again, to like last time, I wouldn't want it to be 0, I wouldn't want it to be 0, I wouldn't want it to be 0. So my domain, n can't be 0. That's not what I got for n, so I'm good with my answer, n equals 2. Okay, let's try one of these that has a little bit more stuff going on in the denominator. So anytime you have binomials in your denominator, you look to try to do some factoring to start with. And so the only factoring I can do would be on this second fraction. And so I'm going to change this x squared plus x to an x plus 1. All right. Once it's factored, let's go ahead and look at what our domain is on this one. And you go through each fraction. So right here, I wouldn't want x to be 0. So I'll write x cannot be 0. But you have to look at every fraction and make sure none of the denominators equals 0. Okay, I'm going to run over here to this one real quick. What would you not want x to be for this? Okay, you should be thinking negative 1, because that would make it be a 0. And then the middle one, I actually have two restrictions. I have just this x, so I wouldn't want it to be a 0. Got that covered already. And then I have this quantity, and again, I wouldn't want it to be negative 1, and I've got that covered. So these are my restrictions for my domain. When I get done, I want to go back and check and make sure I didn't get 0 or negative 1 for an answer. All right, so let's work on solving this. So when I look at what my common denominator is, I go through each fraction and say, all right, this says I have to have an x. This one's got the x. This one does not really have an x by itself. It's got this x plus 1, and remember that's kind of its own group there together. You can't work with that x individually because it's being added. All right, so it does not have a lone x over here, so I'm going to take it times an x. All right, so then for my common denominator, I'm going to go to the next fraction. This says I got to have x. Yep, already dealt with that. But it also says you got to have this quantity, this x plus 1 here. All right, this fraction over here already had the x plus 1. This one does not, so let's take it times an x plus 1. And then if I go to the last fraction, it says x plus 1, which we already dealt with, and then I already had that x. Okay, so it looks like for a common denominator, we're going to have an x and an x plus 1. So on the left side, I'm going to take a 1 and distribute it through those parentheses, which isn't going to do much. It's just going to be an x plus 1. And then right here, this is our first one where we had a minus sign. You got to be careful with this minus sign because it's got to subtract everything. So I change it to adding the opposite, which means I'm going to have the opposite of x and the opposite of 5. Now sometimes I'll have to take that numerator times something. In this case, that particular denominator already had everything it needed, and so all I'm going to do is just continue writing. I'd have a negative x and then a positive 5. Equals. Okay, on this side, I wrote this times x on the bottom. I should have also done that on the top, but you have to do it on both. And so it looks like when I multiply that, I just get an x over that common denominator of an x with an x plus 1. Take both sides times your common denominator. They cancel out. And then I'm going to combine my numerator. It looks like oh, well, look at that. I have an x with a negative x. That's going to totally drop out. And so all I have is the 1 plus 5. And on the right side, all I have left is an x. So that's quick and easy simple or solving. I just got x equals 6. Go back and check in your domain. That works for me up there. So that's my final answer. My x is equal to 6. All right, here's another one. What looks strange on this one to you? Well, there's actually a couple things we got to look out for. This 2 seems kind of weird because it's not a fraction. And then I got this minus out here in front of that. That's kind of weird also. All right, so let's fix both of those. First thing I would do is I would put the 2 over 1 so it looks like it's a fraction. And then this negative on that, I'd probably go ahead and take that negative and distribute it and put it up. It's not really any distributing because it just goes on the 10. So sometimes they'll put that negative out in front. Sometimes they will put it on the side. So I'm going to kind of change it to like adding a negative and put the negative up there for later. Okay, let's do a common denominator. Actually, well, I was going to say we should factor, but there is no factoring to be done. So I guess let's just go ahead and come up with that domain. Go through each fraction. This denominator is a 1. It's never going to be a 0, so no issues there. This denominator is x, so I sure wouldn't want x to equal 0. And then on the last fraction, I wouldn't want x to be a 3, because then I'd end up with a 0 on the denominator. So let's make sure that doesn't end up being part of what we get for an answer. Next thing we're doing is finding our common denominator. So we have to have a 1. Well, that's not really necessary. A 1 isn't going to do anything for us. But we have to have an x, a lone x, not an x that's being subtracted here, but an x all by itself. If it helps you to remember this is its own group, put parentheses on it. So this fraction needs an x, and this fraction will need an x. And then you go to your last fraction, and it says I got to have this x minus 3, this quantity. And that's the only fraction that has it, so I need to put it here and here. So this one also is going to need an x. Here, I'm going to squeeze this in. X minus 3 and an x. X and an x minus 3. And so now let's do an x minus 3 on this one also. Okay, so every denominator is going to have an x and an x minus 3. So then on this fraction, I've got a 2 times an x that's going to have to get distributed into those parentheses. So think of this as a 2x right here. So 2x times x is 2x squared. And 2x times negative 3 is going to be negative 6x. Plus, and then I'm going to the next one where I'm going to be distributing. Now I'm really just distributing a 1, so that's really not doing much. That's just going to be an x minus 3. Equals, I'll have that same common denominator on the right side. And I don't know why I didn't put it up there again. It's going to be taken times an x. Okay, so I have a negative 10 times an x. That's just a negative 10x. Now we're going to try to get rid of those fractions, and so you multiply both sides by that common denominator, so that will cancel out. And then all I have left are the numerators. 2x squared, the minus 6x and plus x combine. All right, now this is a little bit different one because if you'll notice, I have a quadratic left in this. And so if I have a quadratic, I'm going to have to do factoring. So if you're going to solve by factoring, you need to have everything on the same side so that it's set equal to 0. And then factor. And then set each of those equal to 0. So 2x minus 1 equals 0, and x plus 3 equals 0. So my solutions, x equals 1/2, and x equals negative 3. And before I box that in, I'm going to check it in my domain. And so my domain said it couldn't be 0 or 3. I did get a negative 3, but that's okay. So I think both of my answers are good. I'm going to circle them. So I have two options for what I could plug in for x to make this whole original equation be equal. All right. I'm just trying to do like one of several different types that happen. This one here looks a little bit messy, but it's actually probably one of the easiest types that we have. We're going to start off, and you always look at what your denominator is going to be, but then I see this great big long quadratic. Let's factor that thing before we make any decisions on a common denominator. So a and a looks like a 5 and a 4, plus 5 minus 4. And I notice right away, how handy is that? I've got this a plus 5, got this a minus 4. That's going to make getting a common denominator pretty nice since I'm seeing the same thing several times. All right, let's go ahead and talk about that domain before we get too deep into this. You want to look at what's going to make your denominator 0. And so looking at these factors, I would not want a to be a negative 5, because that would make this 0 and this. And I would not want a to be 4, because that's what would make those. So I have two restrictions again. I want to make sure I don't end up with that for an answer. All right, so now let's work on that common denominator. This fraction here says got to have an a plus 5. All right, this does not have an a plus 5, but this does. So this middle fraction is going to have to get multiplied by an, I guess it's not an x, it's an a. Going to have to be multiplied by an a plus 5. The second fraction says I got to have an a, or the second quantity says I got to have the a minus 4. Okay, this fraction already has the a minus 4, but this one doesn't, so let's take it times the a minus 4. And now I think I have everything covered. I've got the a plus 5 and the a minus 4. So that's the common denominator. So this first fraction didn't really have anything going there. The second fraction, and this is where I'm going to add these together into 1. So I've got to have the a plus 5a minus 4 for the common denominator. In this first fraction, I'm going to distribute my 2. I'm in luck because it's a plus sign here. So let's just add and distribute that 5. It's a minus 4 there. Okay, so now let's multiply both sides times the common denominator so that it will go away. Those will cancel, and then all I have left is a plus 14 equals, let's combine some of this, that would be a 7a minus 10. Let's get the a's together. All right, let's add the 10 to the other side. And so you have 24 equals 6a, divide by the 6, so a is equal to 4. Okay, and then as always, we want to check that with our domain, and when I look back up at my domain, oh, finally here's one that has an issue. I had earlier saying that a could not be 4, and my answer here is 4, and so that's not going to work out. So of all that work that I did, and I got a to be 4, a can't be 4, so I X that out, and then I write no solution. Sometimes what you're going to find is you'll have two answers, one of them works, one of them doesn't. That's not a no solution. Then you would just have one of your answers working and you'd put an X through the other. In this example, the only answer I had was one that didn't work, so I've got a no solution. Let's try one more example here. All right, so let's go through and factor denominators if we can, and turn this 1 into a 1 over 1, so it looks like a fraction. So this last one, I could pull a b out of that, so that'd be a b and a b plus 3. All right, so then we have to go look at what will my common denominator be. This fraction says you got to have a b. This does not have a b. The last fraction does have this loose b out to its side, so that's good. Okay, this really just takes care of itself. I don't have to worry about the 1 really. I would care more if it was a 2 or a 3, but a 1, taking everything times 1 doesn't do anything. On the last fraction, I've got the loose b that I was supposed to have, but I need also this quantity, this b plus 3. And this is the only fraction that has it, so the other fractions need the b plus 3. Okay, and so this one also will need a b plus 3, b plus 3. All right, so as I write this common denominator of a b with a b plus 3, on this first fraction, even though there's not parentheses here, I got to think of that as parentheses because I'm going to have to FOIL those two quantities together. So when I FOIL that, I'll have a b squared. Outer is negative 2b, inner is 3b, last is negative 6. Equals, and then I do it again. I'm going to write b and b plus 3, and I'm going to work on writing all of this stuff on one big fraction. So this is really just 1b that's going to have to get distributed into the parentheses. So let's do that. A 1b times b is just b. and a 1b times 3 would be a 3b. And then you got to watch out because look, it's kind of hiding there, but that's a minus sign. I need to take care of that, so maybe if maybe yours is a little neater than mine, but I'm going to go change that to plus, and then I got to change the signs. Change the signs. All right, so now that particular fraction right here was actually good to go on the common denominator. It had the common denominator. It didn't have to get multiplied by anything. I just had to watch out for that negative. So let's just write that denominator negative b minus 5. Then I'm going to take both sides and multiply them by the common denominator so that I can get rid of the fractions. And, oh, I have a b squared here, so there's a good chance I'm going to have to do some factoring. That's a plus b minus 6 equals over here. Okay, did you catch I have an error there? Right here when I took this b times b, I only wrote it as a b. I don't know if I said it right or not, but wouldn't that be a b squared? So then I don't have quite as many like terms over there. And so I'm just going to have the b squared plus 2b minus 5. All right, so I need this, since these are quadratics, I'm going to want them to equal 0. So my first step would be to get everything on one side. But look what happens when I get those b squareds on the same side. They actually are going to end up canceling out. So I really don't have a b squared. I have a b minus 6 and a 2b minus 5. That's not a quadratic to factor. Let's just get the b's together. So b would equal negative 1. Okay, going to box that in, but I always got to check that in my domain. Okay, so if you look back up here, what was our domain? Well, I didn't do it. I should have done it. Sorry. Looking at all the different denominators, this would tell me I don't want it to be a negative 3. This would tell me I don't want it to be a 0. This is a 1. It's never going to be 0, so that's not an issue. So it looks like I'd want to make sure that my b was not 0 and was not negative 3, and that is not what I got, so I'm happy with my negative 1. All right, so I got lucky with my answers here, and all of them worked nicely and didn't have to cross anything out or write no solution, but that will definitely happen on your homework where you have something at some point that will conflict with your domain. Okay, I think it's time for you to try some on your own. Why don't you go ahead and give your homework a shot. Good luck.